Kia ora. In this video, we're going to have a look at an example task. This is a reasonably straightforward one to give you an idea of what sort of questions you might get when you come to do this internal, and then after this, we'll give you a whole bunch of practice ones to do. So let's have a quick look at the task to start off with. This activity requires you to use linear programming to model the constraints Dan has for his farm, to make recommendations so that he can maximize his income in the current year and in future years. You'll present your findings as a written report supported by graphs, equations, and relevant calculations. The quality of your reasoning and how well you link this to the context will determine your overall grade. So, Dan owns a farm and grows onions and oranges. Use the information below to write a report for Dan making recommendations as to how many hectares of each type he should grow. So onions require 71 hours of labour per hectare and oranges require 568 hours of labour per hectare. Onions require 164 litres of fertiliser per hectare and oranges only 41. Dan has a maximum of 40,328 hours of labour and 6,724 litres of fertiliser. Dan must grow at least 16 hectares of oranges and 16 hectares of onions. For the current year, Dan expects to receive $675 per hectare for his oranges and $505 per hectare for his onions. And he's not sure of income for future years, but thinks next year the income for oranges will be about $126.25 per hectare. As you write your report, take care to carefully communicate your findings using appropriate mathematical statements, including graphs, equations, and relevant calculations. So, first of all, we need to define our variables. So the two things that we've got going on is the hectares of oranges and the hectares of onions. So we're going to say that X is equal to the hectares of onions and Y is equal to the hectares of oranges. Okay, so now we've defined our variables. Oopsie-daisies. We want to start writing some equations. So we're going to have some constraints. So, looking at our information, we know that onions require 71 hours of labour per hectare and oranges require 568. So we're going to have an equation here for our labour. So labour, 71 per hectare of oranges. Now, oranges we gave the letter Y, and then, sorry, let's try that again. Onions require 71 hours of labour, and oranges require 568. Now, we know that we've got a total of 40,328 hours of labour available to us. Now, we also have fertiliser. Fertiliser, we need 164 for every hectare of onion, and we need 41 for each hectare of oranges. So that's from there. That has to be less than or equal to the 6,724 litres of fertiliser we can use altogether. We also know that he must grow at least 16 hectares of oranges, so Y has to be greater than or equal to 16, and at least 16 hectares of onions, so X has to be greater than or equal to 16. So now we've got all of our constraints. We want to come along and plop this into Desmos. So to start off with, we're going to, I really wanted to have both showing, so let's try that again. Bring that over there, make it split screen, and then make it a little bit bigger. So we've got our equations here. So we're going to start off with 71x plus 568y has to be, now remember when we put it into Desmos, we flip the symbols around, so we're shading out the bits that we don't want. 40 2328. And we'll just zoom out. Oh, I did not type that right. It should be 40, not 400. Zoom that out so we can see that line. Cool. And then the next one is 164x plus 41y has to be less than or equal to, so we're flipping it around when we put it in, shading out the bit that we don't want, 6,724. Okay, we also know that y has to be greater than or equal to 16, so flipping that round, and x has to be greater than or equal to, again flipping that round, 16. So that gives us our feasible region here with these 4 points as our critical points. So what I'm going to do is we will quickly take a snapshot of this, pop it into our doc, and then we will continue. Right, so let's come back now to our, oh, that is not our Jamboard, to our Jamboard, and hopefully this has picked up our second page. It has not. Right, so now what we're going to do is we're going to label the things that we've got going on this graph. So first of all, we need to make a little note on here to say that I have shaded out the sections I do not want. So I flipped the signs. So now what we're going to do is we need to label this here as our feasible region, and our critical points, the corners, this here is 3716, this one here is 1616, this one here is 2468, and this one here is 1669. Now, if you get that far and you've drawn your graph, you've labeled it correctly, this here is going to give you an achievement grade. So now let's go on and have a look at what we need to do from here. Firstly, we need to look at the current year. So let's come back and read our income prediction. So for the current year, he expects to relieve 675 per hectare for oranges and 505 for the onions. So for the current year, the profit is equal to 505x, because we got $505 for the onions, plus 675y, because we got 675 per hectare for the oranges. So for each of our critical points, we have our coordinates, which were 1616, 1669, 2468, and 3716. So what we're going to do now is we're going to put in our profit. So 505 times 16 plus 675 times 16, popping that coordinate in, gives us a profit of 18,880. Second point would be 505 times 16 plus 675 times 69, which gives us a profit of 54,665. Next one is 505 times 24 plus 675 times 68, which gives us a profit of $58,020. And 3716, 505 times 37 plus 675 times 16 gives us a profit of 29,485. So looking at that, which one gives us the most profit? It's this one. So we're writing this report for Dan, so we want to put it nicely in context. We want to say Dan should grow 24 hectares of onions and 68 hectares of oranges to maximize his profit and get $58,020. Okay, now if you get that far, that is a good solid merit. Now, what we want to think about now is the final part of the assessment, which is the future years. So we're told in future years, he's not sure of his profit for the oranges, but he thinks it's going to be $126.25. So that means our profit equation becomes 505x, because we haven't changed the amount for the onions, plus 126.25y. So let's put that into our onions and oranges and our profit. And the points that we had were 16, 16, 16, 69, 24, 68, and 37, 16. So if we put those into our profit equation, we get 10,100. We get $16,791.25. And we get 20,705 and 20,705. So both of these, which means anywhere along the line that joins them, give us the maximum profit. So let's write this as a sentence. In order for Dan to maximize his profit, he needs to grow any combination of onions and oranges that lie on the line segment between 24 hectares of onions and 68 hectares of oranges, and 37 hectares of onions and 16 hectares of oranges. Okay, now we want to think about a few more things here. So at this point, you want to think about whether or not integers are important. So in this particular case, integers are not important because you can plant half or a quarter or 10% or kind of any fraction you'd like of a hectare, and that's okay. So in this case, integers aren't important, but you do need to be thinking about it if they are. So the equation for this part would be, and let's come and have a look at Desmos for a moment, or actually just look at our graph. So anywhere along that blue line is our important, are the line of critical points. So the really important part, the part that satisfies the condition and gives us the maximum profit. So that blue line is the 164x plus 41y has to be greater than or equal to 6,724. So the equation is 164x plus 41y equals, because it ends up being on that line, 6724. So if we rearrange that, we get y is equal to 6724 minus 164x divided by 41. So if we put that into context, the hectares of oranges, because that was the y, is equal to 6724 minus 164 times our hectares of onions divided by 41. And we know where the hectares of onions is between 24 and 37, which is what we knew from our critical points. Now, the last thing you can be thinking about here, and we'll call this extra for experts, is explaining why this is the case. And sometimes for excellence, rather than explaining why it's the case, you might have to come up with a solution that does cause multiple solutions. But in this one, we're just going to explain why this is the case. So the profit equation, or the profit for onions, I should say, in future years was 4 times that of the oranges. Because if we think about what that was, coming back here, it was 505 versus 126.25. This matches the 4 times limit from the fertilizer. Which was 164 versus 41. Which is why there is multiple solutions. As these gradients match. Okay, and if you think back to our last lesson where we were sliding those lines down, because that gradient of that profit line matches the gradient of that fertilizer equation, that means that there are multiple solutions. And if you get that far and do a good job of that, that is an excellence. So what we want you to do now is we want you to do a bunch of practice. So on the Google Doc, there is a whole bunch of practice exercises that you can do, as well as a link to a generator, which will make as many as you'd like. So there's no reason why you can't do lots and lots of practice. And then when you're ready to sit it, you just need to let us know.